Welcome to session. Today we'll discuss about the characteristic and location of images formed by convex and concave lenses. So focus on the screen. So here in the first white box on the left side, the incident rays are parallel to principal axis. Here consider an object which is at infinity, which is at a very large distance, for example sun. So sun is considered to be at infinity. The distance is at infinity. So the rays from sun would be parallel to the principal axis. So here the object is not shown and is assumed to be at infinity. So the rays from an object which is at infinity would be parallel to principal axis. So here u is the distance measured object distance measured from optical center. V would be image distance measured from optical center. F would be focal length measured from optical center. So here U is infinity. That means it is very large distance. So one example is sun, it could be stars or other planets. So here when such incident rays which are parallel to principal axis, they refract through a convex lens. The lens after refraction converges these incident rays to a focal point. So here the image formed is at the focal point. First of all, the image formed is real. Second, the image is extremely diminished, almost to a point. So here the image is formed at f2. So it is extremely diminished and it forms at focal point f2. And third, the image is erect. Okay. Image is inverted, not erect. Image is inverted. So if you see here, the image is formed at focal point. So f2 is the focal point. And note that object is on one side and the image is formed on the other side. So here the image is formed at focal point and on the other side. Next, image is real, image is inverted, and image is extremely diminished, almost to a point at focal point. Okay. So such a phenomenon or such a lens is used in burning glass. So when you must have seen a burning glass. When you use a burning glass to focus on a piece of paper, you are concentrating the parallel rays, incident light rays from sun onto the paper, that is the focal length of the lens. We are adjusting the distance between the burning glass and paper such a way that the image of sun is formed on the paper and then it starts burning. So this is an example of first case when the object is placed at infinite distance. So when object is at infinite distance, the image is real, image is formed on the other side, image is inverted, and image is extremely diminished almost to the point. Now see the second case. When the image is placed at a very large distance, for example, a tree in a park. So it is quite distant, it is at a quite large distance from the lens. Okay, it is a very large distance. Here, the incident rays from an object such as a tree would be parallel on the lens, but they are not parallel to the principal axis. You cannot guarantee that the incident rays coming from an object which is placed at a very large distance are parallel to the principal axis. They are mostly oblique to the principal axis. So if you see here, the parallel light rays, here the object is not being shown. So this object is at a very large distance. For example, a tree in a park, which I told you, or a high-rise tower which is far away. So such incident rays are parallel to each other, but they are oblique to the principal axis. So they are not parallel to the principal axis. When such a beam of light rays is incident on a convex lens, as shown in the figure, so this convex lens, it converges such rays, and an image is formed on focal plane at focal point f2. Okay, an image which is shown as a dash b dash here in the figure. An image is formed of the object which is not shown here. So if you notice, the image is formed on the other side of the lens. The image is inverted. The image is real, and the image is highly diminished. Actually, we could not show the object here because the object is so large. But if you see the image, it is almost depictable on this diagram. So the image is highly diminished. So in this case, when u, that is the object distance as measured from optical center, is very large, an image is formed on the focal plane of the focal point on the other side of the lens. So here if you see, image is formed, it should read focal plane actually. Image is formed at focal plane at focal point f2 on other side. Okay. Then the image is real, the image is inverted, and the image is highly diminished. Okay. The example of such a lens is used in a camera where you picture like long distant objects. Okay. Let's move on to next scenario where the object is placed beyond second focal point. If you see on the left side, this is the first focal point and this is second focal point. So when an object is placed beyond second focal point, then an image is formed between f2 and 2f2 on the other side of the lens. So any object that is placed beyond second focal point, its image is formed on the other side between focal point and second focal point. Okay. So here, if you see, the image is formed between focal point and second focal point. See here, this is the focal point and this is the second focal point. So the image is real, the image is inverted, and image is diminished. If you see, image is smaller than the object. Okay, so when the distance is greater than second focal point, an image is formed on the other side of the lens. So object is placed is after second focal point on left side. For such an object, an image is formed between focal point and second focal point on the other side. Here, a real image is formed, an inverted image is formed, and a diminished image is formed. Okay. So the position of an object is beyond 2f1, whereas the position of the image is between f2 and 2f2. Okay. Such a lens is again used in camera to picture far objects. Okay, let's move on to next. Here, when the object is placed at second focal point, okay, then an image is formed at second focal point on the other side. Here, the image is formed on the other side. The image is real, and the image is of equal size as the object. Okay. So if you see here, image is placed at 2f1, whereas object is placed at 2f1, whereas the image is formed at 2f2. Okay, and the size of the object and size of the image are same. Okay, so here if you notice, image is formed at second focal point on the other side of the lens, the image is real, the image is inverted, and the image is of same size. Okay, so infinitely placed object image is extremely diminished. Very large distant object image is highly diminished. Beyond 2f, if you are placing the object, the image is formed between f and 2f on the other side, and the image is diminished. When the object is placed at second focal point, the image is formed at the second focal point on the other side and is of equal size. In all these cases, the image is real, image is inverted, and image is formed on the other side of the lens. Okay. Now, when the object is placed between 2f1 and f1, that is focal point and second focal point on one side, when the object is placed, an image is formed beyond the second focal point on the other side. Here, object distance is greater than focal length. See, this object distance is greater than focal length, but is less than 2f. So it is less than this 2f distance. Okay. So here, when the object is placed between 2f and f, an image is formed beyond 2f on the other side. If you notice, the image is formed beyond second focal point on the other side. The image is real, image is inverted, and image is magnified. So you must notice this. Till now, like at second focal point, image was equal in size with object, and when it was beyond the second focal point, image diminished in size. But here, the image started magnifying. So the example of such a lens is used in cinema and slide projectors. So here, so the image is magnified. So they will, because the image is also inverted, they will use a film which is inverted and which is placed very near to focus. Then they will get a magnified inverted image on the screen. So this phenomenon is used in cinema and slide projectors. Clear? Now, when the object is placed at focal point, if you see, the object is placed at focal point on the left side, then after refraction, the incident rays, they travel parallel to each other. So in this case, a very large image is formed at infinity. So here, if you notice, the image is formed at infinity on the other side. The image is real, the image is inverted, and the image is highly magnified. Okay. And such a lens is used in collimator of a spectrometer. See, a spectrometer is a device to analyze any spectrum. For example, a light spectrum. Light is made up of spectrum of wavelengths from red to violet, Vibgyor. So to analyze such a spectrum, a spectrometer is used. In spectrometer, the input to a spectrometer is a parallel beam of source of spectrum. So when you are taking any source of spectrum, which is a point source, so you won't get parallel incident rays from a point source. So the collimator is a device. Collimator is a device which converts this diverging incident rays from a point source of spectrum to parallel rays. So this is how this lens is used in collimator of a spectrometer. Okay, let's move further. Now, if the object is placed between the focal point and the lens, see the lens surface is here, this is the optical center, and this is the focal point. So the when an object is placed between focal point and lens, that is, the object distance u is less than focal distance. This distance is less than focal distance. When that is the position of the object, then if you see, the refracted rays are divergent, so they will never meet. So when you draw such refracted rays backwards, they appear to meet at point A dash. So here a convex lens is forming a virtual image. This is not a real image. A virtual image is formed, and a virtual image is formed on the same side as the object. So whichever side the object is placed, the image is also formed on the same side, and then the image is magnified. See the object size, and the image size is magnified. Okay, such a convex lens is used in magnifying glass, or in reading glasses, or even in a simple microscope. Okay, so if you notice, image is formed behind the object. See, here is the object, behind the object, on the same side. So image is not from the other side of the lens, but on the same side of the lens. Then image is virtual. So this is not a real image, this is a virtual image. The image is erect. So if you see, image is not inverted but erect, and image is magnified. So this is the size of the object, whereas the image size is magnified. So such a lens is used in magnifying glass, reading lens, and simple microscope. Okay, clear? So to summarize, when an object is placed at infinite distance, a real, inverted, extremely diminished image is formed on the other side of the lens at focal point. Okay. When the object is placed at a very large distance, that is, the incident rays are parallel but oblique to principal axis, then the image is formed on the focal plane, or at the focal point only, but on a focal plane. At focal point, if you draw a focal plane, the image is formed on the focal plane. Here the image is highly diminished, image is real, image is formed on the other side, and image is inverted. Okay. Now when the object is still moved closer to the lens, but it is placed beyond second focal point, in such a case, the image is formed on the other side of the lens, and the position of the image is between first focal point and second focal point on the other side. Here the image is diminished, image is real, image is inverted. Okay. Now if you move the object to second focal point, that is to f1, in this case the image is formed again on the other side of the lens at the second focal point on the other side of the lens. Here the image is real, image is inverted, image is of same size as that of object. So here you see, slowly this image was diminished to the point. This is extremely diminished, like highly diminished. This is extremely diminished to the point. This is highly diminished. This is diminished. Now it became equal. Okay. Now you see, it started magnifying. When the object is placed between second focal point and first focal point, then a magnified image is formed again on the other side beyond second focal point. So when the object is placed between second focal point and first focal point on one side, its image is formed beyond the second focal point on the other side. Here the image is again real, inverted, but magnified. So here you see, when it is at second focal point, it was of same size. Once you are moving closer to the lens, then the image is starting magnifying. Now when the object is placed at focal point, then the image is largely magnified and the position of image is at infinity. Okay. Then when you place the object between the focal point and lens, okay, here the image is formed on the same side of the lens, the image is magnified, image is erect, and image is virtual. In all other cases, image was real, but when you place the object between focal point and lens, it is virtual. So if you see the applications, okay, this the first kind is used in a burning glass. The second kind is used in a camera for picturing distant, very far distant object. Then the third kind is used in again camera for far objects. Then the fourth kind, it is used in a terrestrial telescope. Terrestrial telescope is a telescope that you use to see long distant objects on a territory. So it is called terrestrial telescope. Here the image is actually inverted, but for the observer to see the image erect, this lens is used to erect the image. So inverted image is actually converted to an erect image using this lens. Now the next lens, it is used here when the object is placed between second focal point and focal point. The image is magnified and is found beyond the second focal point other side. So this is used in cinema and slide projectors, where the actual object is inverted and it is very small. You get a magnified image which is inverted, so it is erect. Okay. Then when you place the object at focal point, then extremely large image, magnified image is formed at infinity. So this is used in collimator of a spectrometer. And the last kind, where the object is placed between focal point and lens, here a virtual image is formed on the same side of the object. It is formed beyond the object and it is magnified and it is erect, and as stated already, it is virtual. Okay. So let us look at the characteristics of formation of image using concave lens, the position of the image as well as the characteristics of image formed by concave lens. So in the first white box, focus here. So here again the object is placed at infinity. So incident rays are parallel to the principal axis and a virtual image is formed at focal point on the same side of the object. Okay, so here you see the image is virtual, it is not real. The image is erect and the image is formed on the same side of the lens. Okay, here the distance is infinity. So if you notice, image is formed at focal point, the image is on same side, it is virtual, it is erect, and it is extremely diminished almost to a point source. Okay, such a lens, concave lens, is used in Galilean telescope. Okay, when the object is placed at a very large distance, like a tree in a park, as I told you earlier, so the incident light rays are parallel to each other, but they are oblique to the principal axis. Such incident light rays, then an image is formed on the focal plane at the focus on the same side of the lens. So here the object is not shown. because it is at a very large distance and it is very big. So now here when you draw the refracted rays backwards, so the image is formed at A dash B dash. So this image is virtual, it is diminished, highly diminished, and then it is also erect. It is formed on the same side of lens and it is formed on the focal plane. So earlier, when the incident light rays are parallel to principal axis, the image, extremely diminished image, is formed at the focal point. So this is extremely diminished almost to a point. Here it is highly diminished, therefore the image is formed on the focal plane at the focal point. So in both the cases, the image is virtual, image is erect, image is formed on the same side of the object, and then in this second case, the image is highly diminished. In the first case, image is extremely diminished to the point. Okay, so these kind of lenses are used in Galilean telescope. Now, there remains just another case for the concave lens, when the object is placed beyond second focal point. Okay, so consider an object placed at AB. Now an image is formed as A dash B dash. So if you see, this image is formed between focal point and the lens, and then image is diminished, image is virtual. Okay, so if you notice, image is formed on the between focal point and lens on the same side. So this is focal point and this is lens. So the image is formed between focal point and lens on the same side. The image is diminished, image is erect, and image is virtual. Image is formed on the same side of the object. So such a lens is used in spectacles for short-sighted persons. So the people who can't see long distance objects, for them the image is formed very near in front of their eyes. Okay, so they can see the long distant objects as an image. So such a lens is used in spectacles for short-sighted persons. Okay, so in summary, before we go for summary, in concave lens, so the object, when it is placed at any distance, again then the image is always formed between focal point and the lens. So even if you move the object to f2 or between f2 and 2f2, the image is always formed between focal point and lens. That is the reason why we are considering just this one case. Even when the object is moved closer to the lens, until focal point, the nature of the image and the position of the image doesn't change. What I mean to say is, the position of the image may vacillate between focal point and lens, but and the image diminution may be to a different scale, but it is always formed between focal point and lens, and it is always diminished, it is always erect, and it is always formed on the same side of the object. So that is the reason we need not consider object at 2f2 or anything. But when the object is placed at focal point, the image is formed exactly at the midpoint of the focal point. That you should remember. So whenever the object is placed beyond 2f2 or beyond f2, the nature, position and characteristics of the image formed would be same. Okay, but even when it is placed at focal point, then characteristics of the image remain same and the position of the image also remains same, that is between focal point and lens. But when the object is placed at exactly focal point of a concave lens, the image is formed at the midpoint of the focal length. Okay, so in all cases the image is formed on same side, image is virtual, image is erect. Okay, so that's the reason we don't have to consider any other positions of the object for concave lens. So in summary, concave lens, when the object is at infinity, when the object is at infinity, a virtual image is formed on the same side of the object, and it is which is extremely diminished to a point. Image is diminished to a point. The image is erect, image is virtual, image is formed on the same side at the focal point. Such a lens is used in Galilean telescope. Then when we move the like closer to the lens, that is, but still the distance is very large, like a tree in a park. So here the incident rays are parallel, but they are oblique to principal axis. So for such an object, an image is formed on the same side of the object, which is virtual, which is diminished, and it is formed in between the object and the lens. Okay, so example is Galilean telescope. Okay, so the third kind is when the object moves closer but beyond second focal point. Okay, for that matter, till the focal point, you place the object anywhere, the image is formed between focal point and lens. It is always erect, it is always virtual, it is always diminished, and it is always formed between lens and focal point. If you bring the object to the focal point, then the characteristics of the image remain same, but the image is formed again between the focal point and lens, but at the midpoint of the focal length.